It's my pleasure to welcome you all for this exciting webinar that you're all going to be part of in about a minute or so. We have with us William Harrison. He is from NIST, the National Institute of Standards and Technology, a very, very important government research organization in the United States. He's a mechanical engineer. William S. Harrison III is a mechanical engineer in the Department of Commerce's National Institute of Science and Technology. William works in the Intelligent Systems Division on the Agility Performance of Robotic Systems project. His research focuses on devising metrics for assessing industrial robot agility and intelligence. So William's specialty within the project is virtual fusion, a mix of simulated and real approaches for process validation and machine learning. Okay, his interests include virtual reality, game engines, augmented reality, and 3D modeling. All sounds very, very, very exciting. So over to you, William. Look forward to hearing from you.
All right. So I am honored to be here. So just so you know, for those of you who don't know, this video is not actually of a real robot. It's from a movie, but I think it's a good talking point, because if you go far back in our history, more than 100 years, robotics are there. The idea of a robot, right? And the idea of artificial intelligence. And if you look in our popular country, robotics serve two different places, have two different places in our minds and hearts. One is the good guys, helping us do interesting things, helping us live, and then also, saving the day when we need them to save the day. And on the other side, we are deathly afraid of robotics. We're deathly afraid of artificial intelligence. But whether you believe one or the other, I think we can all agree that robotics and robotic systems are definitely a part of the future as we see it, particularly to manufacturing. But is this really the future? So what I'm going to cover for you, it's not a very long presentation, at least I don't think it's very long. What I'm going to cover for you today are the three initiatives that we're doing here in my group in this, that I think we're looking for collaboration, participation, and just free conversation between us and anywhere and anybody on the planet. So the first initiative is robotics education. So our ability to produce competitive programmers and systems and users are hampered by our inability to train them. So out of 3,567 total schools in the country, 36 have some kind of formal robotics program. So that's roughly 1% of all the schools that we had access to in this study have a formal robotics program. 14 have masters, 8 have PhD. At the time of this, that has actually grown. This research was probably a few years ago. That has actually grown, but we're talking about a very minuscule amount of education that's available for those who want to specifically focus in robotics. So that leaves basically 3,500 schools that do not have access to directed robotics. So one of the reasons for this is obviously cost, hiring faculty, course resources, but there's a huge potential for impact here. So there in the United States, 25,000 this is the world, 25,000 colleges and universities in the world, 220 million college students, and basically none of them have access to specific education in robotics. So we think robotics are the future, but that's not actually the future we're creating in a lot of places. And if we're going to talk from a particularly industrial perspective, there are about 597,000 manufacturers just in the United States, 293,000 installed robots, which sounds like a lot. but that averages out to roughly half a robot per manufacturer. And we know that it's not evenly spread. So many manufacturers, especially in the small to medium size, are not using robotics, are not doing much automation. The process is mostly manual. Worldwide, 2.7 million installed robots, which also sounds like a lot, but 73% of all the robots installed on the world are in China, Japan, USA, Korea, and Germany. There is a huge place for impact when it comes to automation and robotics on our manufacturing and our manufacturing economy, not just here in the United States, but all over the planet. So one of the reasons I'm citing a study here that McKinsey did, one of the reasons for that is knowledge of how to implement the systems, the cost of the robots, obviously, lack of homogeneous programming platform. And this is a quote that I thought was poignant. It is a challenge to identify opportunities of how to apply new technologies. So this all comes down to people who are involved in manufacturing and in the world not having access to the information they need in order to be able to utilize robotics and automation. So this is a quote from a company called Intrinsic here that I thought was poignant. So millions of businesses and people around the world don't have access to these robots to work, build, and do things, but what if they did? So one of our initiatives is about trying to, is this the right, okay, we're in the wrong direction. Is about trying to bridge this gap. So I don't know how many of you are familiar with the MNIST database, but it's a database that people all over the world have used to try to learn neural networks and convolutional neural networks and how to use them. And that's something we're interested in doing in robotics, is providing a platform that is the gateway for more people to learn about robotics and also have the use and ability to have robots in their research and education programs. So many of the potential robot users of the world would have access to robotics if we were able to do that. So we want to get these tools and abilities in the hands of people all across the planet. So our first initiative we called the Modular Open Source Robotics Testbed. So simulation, if we're talking about robotics, is always free. But imagine if robotics were cheap and easily accessible. And that's the idea behind what we affectionately call MORT. Low cost, user assembled, open source robotics testbed. It's an environment that schools and manufacturers all over the planet could potentially utilize for training without having to go broke in order to be able to use the different hardware. And the main uses for this would be robotics benchmarking, research recreation, and training and education. So just some important aspects of MORT, like I said before, is for education, training, and research. But what's important as we try to facilitate the creation of MORT is that it be low cost. We want anyone on the planet to be able to utilize this testbed that we're trying to create. We've done some research and we see that in the 1K, 10K, and 30K, depending on where you are, in what university you are, and what kind of funding you have. These are the kind of the funding sizes that we're looking at in order to be able to create something like this. We want it to be modular and user assembled, right? So we don't want it to be specific to any manufacturer anywhere in the world. So anyone on the planet should be able to create this robot from off the shelf in 3D printable parts. So what we're looking for here is collaborators in the design of this. We would like to move forward in 2024 and 2025 in the creation of more and also the justification. So understanding is it something that professors and schools need? Is it something that industry would really benefit from? So there are many times during this presentation where I'll talk about what kind of interaction we're looking for. And for this is the type of interaction we're looking for. On all my slides, you'll see on the bottom right side, you'll see my contact information. Please reach out today, possibly, if you are interested in this or anything else I'll be talking about. So there are a couple of open questions when we think about this open robotics test bed. So what's the cheapest possible robotic system capable of meaningful robot training and manufacturing? This is an open research question. The accompanying question to that is what robotic setup / hardware would allow for the most use in manufacturing robotics research, particularly robotics training algorithms and platforms. This enters our other initiative, also along these lines, called the International Industrial Robotics Capstone Project. So for those of you who are not familiar with the Capstone Project model, students, usually students in college, sometimes grad school, have a project for their class. I think pretty much every country has it. Not everyone calls it a capstone project. But in this capstone project, they're trying to close the gap between they're trying to create this robot that we were talking about as a part of more, right? We call this investigating the back edge of technology, which means what's possible with the least resources. And we thought about funding a university grad school for this, but we actually decided that this could be, because of who we want to be able to use it, actually accomplished by a group of undergrads. And the creation of this robot helps us as creating a proving ground for some of the metrics in robotics that we are doing. So we call this the INI RCP. It's multi-continent, multi-country, multicultural capstone project. It's comprised of students from all over the world, hopefully, and the objective is to design an industry-capable robot from 3D printed and off-the-shelf components capable of being built in multiple countries. So each group is composed of students from different countries, and they work together to design this robot. Right now, as a part of this, we have 2 universities from the United States, Louisiana State University, Lake Superior State University, and then 1 university in Mexico, Monterey Technical University, and German Jordanian University. So this is something we would definitely like to see a lot more of. Just to give you an idea of how much something like this costs, because we are very interested in people participating very soon. If you're interested, in the United States, this costs roughly $70K per school. But that includes travel, faculty time, and because these groups are spread across the country, it's a great opportunity for them to travel somewhere else. So as a part of this process, we'd like for every group to have the ability to travel to one of the partner locations. That's one of the reasons why it's so expensive. Right now, LSU, Louisiana State University, is managing this. That's what allows us to have multiple schools from all over the planet. These are some of the rockstar professors who have signed on, who are interested in trying to do this for the first time. But we'd like for this list to get much longer. So we're looking for people who are interested in participating in 2024 this year, or 2025 next year. So like I said before, that's my contact information. Please contact me if you're interested in participating in some way. So the next initiative is what we're calling Industry Connection. So as we think about NIST mission, which is to basically help US industry through metrics, science, and technology, in order to do that, there needs to be a free flow of information and technology transfer between industry and academia. And we have a saying here, because my group is specifically focused on robotics. So robotics research realizes its greatest value when it makes its way to industry. And having that thought in mind has pushed us to do certain things to facilitate this connection between industry and the knowledge transfer between those who use information and those who consume it, which is essentially everybody, right? But one of the challenges to this is that small to mid-sized enterprises are not aware of the state of the art, right? If you have manufacturers, I know here in the United States, based on some of the research and conversations that we've had, small to medium-sized manufacturers, they don't have the time to understand what the state of the art. They don't have the resources and expertise to delve into what's possible, to go to conferences, to read articles, not necessarily, and even necessarily just to talk to the suppliers that have access to ready-to-use technology. And there's not a good platform for understanding the state of the art. Yes, there are trade shows. Yes, there are conferences, but these are not well suited for those people in industry. On the academic side, interestingly enough, what we're also finding is that academics are not completely aware of the state of the art of industry. They don't have a good understanding of what the challenges industry is facing. And that's because industry doesn't publish that kind of thing, right? There's no benefit in the short term for a manufacturer to publish about all the issues they're having and where technology is failing them. So these are the challenges. What we would like to see happen is industry-driven research, right? Academics need a clear picture of what the industry needs. And on the industry side, we need informed, non-redundant innovation. And what that means is that when innovation happens, when challenges are met, when discoveries are made, there's licensing and publication and patents and ways to disseminate that information in a fair way so that the community can then build on that information. So that's the goal. What are we doing to try to address that? So we are doing some workforce efforts that I will talk about with ARM. We'd love for you to be a part of. We're doing some industry connection activities, specifically on a smaller scale. And we have something called the Agile Robotics for Industrial Automation Competition, which we would also like for you or your students and people you know to participate in. I will go over each of these. So in April 16th, I believe, we are partnering with the Advanced Robotics for Manufacturing Institute, which is a nonprofit institute here in the United States. And they have something called roboticscareers.org. And it's a place where students or potential employees can put their information who are interested in being hired for companies that are looking for people with robotics type qualifications. So we're doing a workshop in April, like I said, and in that workshop, we're thinking about new ways to do short-term or short scale workshops to help connect employers to potential employees. So we're going to talk about things like how to create your social media profile, right? So when I originally was applying for the job I didn't have to do anything with social media. But now that's just a part of being a responsible adult, like how to create that social media profile, how to use the internet and the different job search profiles in order to connect. We're going to have different employers here in the area talk about what it's like in robotics where they work. And this is something we'd like to replicate at conferences and schools all over the country and potentially all over the world. If you're interested in taking part or collaborating with that, please contact me. Also, we have some smaller efforts also. We have a publication that we are working on. We're focused on working with industry to produce an industry trends and challenges document. And it's basically highlighting the gap between industry and academia in a way that helps industry know what's available and helps academia know what industry needs. And that's probably in the 2025 timeframe, but we're definitely looking for people to collaborate with, be it in industry or academia. The other thing is happening tomorrow. So if you're interested, please send me a message. This is going out via Outlook invite. So if you're interested in this, please contact me as soon as possible. It's happening 12:30 tomorrow. Professor Jim Dever-Prasad from Lake Superior State University is going to be giving a talk on robotics automation and the gap between industry and academia. So along the lines of what we were just talking about. That is 12:30 Eastern time tomorrow. If you would like to attend that, we would love to have you and have the discussion about where these gaps are. That is tomorrow. Please reach out to me if you're interested. We are also working on a workshop in 2025, which we would love to have participation from all the people here along those same lines of looking at industry trends and highlighting the information that's useful to both academia as well as industry. So the third and final initiative is probably the only thing that I'm going to talk about with metrics. So NIST is usually very focused on that metrics. What I talked about previously was not specifically about metrics, but this one is. So we run a competition called the Agile Robotics for Industrial Automation competition. We've been doing this for the better part of a decade. We call it ARIAC. And ARIAC is a completely simulation-based competition. It's one where students are, it's not actually all students. Typically half of our participants are grown people actually. But the challenge is a manufacturing challenge done completely in simulation where they have to overcome different agility challenges. And agility challenges can just be summed up in having a robotic system function in a highly dynamic and sometimes unstable environment. This is a prize competition where first place wins 10,000, second place wins 5,000, and third place wins 2,500. This is open to anyone on the planet. And in fact, if at least one member of your team is from the United States, you are eligible for the prize. So we've had students from classes, we've had classes completely taught around this competition. And we've also had professionals who've been working in robotics for the last 30 years also compete and win this competition. So if you are interested in finding out more information about the competition, we would love to have you take a part. So like I said, this was not going to be a super long presentation. If you're interested in one or all of the things I talked about, please reach out to me. This is my contact information. If you're specifically interested in ARIAC or more, here are the QR codes for that. And if you have any questions, I am here to answer.
Fantastic. Well, William, this is a outstanding presentation, short but very stimulating. I think a lot of thought for discussion, and let's hope we can generate some discussion from our audience here. We're about 60 people. Just jump right in, raise your hand if you want to, unmute yourself. It's an exciting area, and William has given us 3 avenues for doing something about our interest in this field. So you can put a chat message if you want to. Either way, chat, unmute yourself, raise your hand. Absolutely, James, go ahead. Yeah.
So, William, thank you very much for a fascinating presentation. I think the thing that fascinated me most was to realize that the world of robotics, particularly in the US, seems to have remained static for the best part of 30 years. You know, I can remember when people were making the same comments as you have made tonight in the 1970s, forecasting that by the mid-90s, there would be nobody working in factories. All factories would be automated. And of course, that didn't happen. And so in the mid-90s, I encouraged one of my PhD students to investigate why this hadn't happened. And he ended up by thinking, he said to me, that's much too difficult a question. I want to do something simpler. And he went and devised the robot that we put online on the internet. That was on the internet for about 10 years before it became too expensive to maintain. So, you know, that was a wonderful project, but stimulated by that question. But you know, perhaps I might be provocative here and say that when I observe what's happening in Australia, my country, um, I see companies large and small developing their own robotic systems without great difficulty. In fact, they don't come to universities and say, hey, we're really stuck. How do we do this? They just get on and do it. And I don't observe the reluctance to use robotics that you have observed in the US. It's really interesting and intriguing. Uh, and, you know, if you look at the function of universities and particularly engineering schools, our job is to provide a fundamental education which prepares our students to be able to solve, you know, to undertake projects and to provide solutions for companies that want them without necessarily having to come back to us and ask, how do we do this? And so, for example, we don't see courses on large electric motors in most universities. We don't see courses on blast furnaces. We don't see courses on a whole host of technologies which have become standardized. You buy them off the shelf. You can find out how to use them from companies and suppliers. And I would suggest that robotics perhaps is actually sitting in there. It sits as one of those technologies which you can access if you really want to, without having to refer to a university, even if you don't have people who have been specifically trained in a robotics program. As long as they've received a good engineering education, they can pick it up and run with it themselves. So I question this idea that you need to have specific robotics programs, except in a small handful of universities where you'd expect them to be advancing the state of the art and supporting companies like Boston Dynamics with their jumping robots and so on. I know Stanford are doing a lot and so on and so forth. So I'm putting it out there as a provocative question. And perhaps the elephant in the room here is what I would refer to as AI, but I refer to it as artificial incompetence. Because for decades, robotics researchers have presumed that artificial intelligence is going to come to the rescue. When robots really have true artificial intelligence, we won't have any of these problems. And to me, it strikes me as a bit like fusion energy. You know, the longer we go on, the further fusion power seems to be away. And again, you know, I go back to books that I acquired in the 1960s that confidently forecast that robotics and automation would conquer the world in 3 or 4 years. And it just seems to get further and further away. And I think that maybe there's some fundamental issues here that we are not facing up to. So there's a whole lot of provocative questions for you to think about.
Okay.
And please, if I duck out in a few minutes, it's late at night here in Western Australia.
All right,
Yes.
you gotta respond to a lot of different things that James has brought up. Take
Yeah.
the mic.
So as far as the technological development of robotics, so what we've seen probably over the last 30 years is that robotics themselves have not had a huge amount of advancement if we're talking about the hardware. Like if you crack open a robot and you look at what's inside, not a lot has changed. They are very precise and capable of doing, you know, repetitive motion. But what we have seen explode in the last 15 years is the software surrounding robots. And what we've seen explode in the last 5 years is the software that helps them understand their environment. And this is the place where AI makes the biggest impact, is in the software that supports robotics. And people are starting to use some of the same emergent technologies that they're using for perception, and such as convolutional neural networks and generative AI, and apply that to robotics. So things are moving so fast right now that it's hard to say whether this problem of the technological advancement of robotics and having it be applicable to new and more interesting applications. Maybe it's 10 years down the line, but things are moving so fast, it could easily be 10 months down the line. because we're so good these days at spinning up new technologies and new companies. We can do that in months. So as soon as there is a new advancement, there's immediately some company to jump on that. So it's an exciting time. So to also address the comments you had about education and in robotics. So it's true that robots are a commodity. I think that's what you were getting at, right? But the problem is that when I was talking about robotics education, is that manufacturers, small to medium-sized manufacturers, many of them, and this is not the United States, we're talking about the planet, many of them are just not aware of what's possible, right? And their inability to understand, not really inability, the fact that they don't really know what's possible is inhibiting their ability to use these technologies. You said, for example, they can just with a little bit of effort buy the robot and then go implement it. It's more complicated than that. There's an entire ecosystem that surrounds the integration of robotic systems, which are called integrators. And that's the case whether we're talking about the United States or we're talking about Asia. But a lot of the people who manufacture things, we're talking about hundreds of thousands of companies. They're just concerned with making their widget, right? They don't have time to think, okay, what's the best way to do that? And the only way that information gets into their organization is when they hire someone who knows it.
Okay, that's something exploring there. Question from the audience in the chat box, William, is can you I mean, some other universities are doing research in robotics, and they're wondering if you can highlight a few state-of-the-art topics for research in some of the universities that should be interesting.
Yeah. So the robotics areas span a lot of different aspects, but it actually turns out there's not a lot of research in new types of robots. There's some research in soft robotics, underwater robotics, but it turns out that a lot of the research surrounds on the capabilities of the existing robots, right? So there's research in reinforcement learning, which is a type of machine learning that does not require training. This is an open area of research. There's a lot of research on grasping, helping robots to figure out how to best grasp and avoid areas. But it's limitless, but those are just some examples of where the research areas are in robotics right now.
Okay, let's hear from others. Anybody else in the audience want to jump in and make a comment or suggestion or question? Have time for that. A lot of them want your presentation. We will be having a recording of this session, so if we will send you the recording, okay? I have a question here from Israel. In your opinion, what are the main weaknesses we have in our industrial engineering study plans?
Industrial engineering study plans. Okay, what do you mean by study plans?
You want to speak, Miguel? Unmute yourself. It might be curriculum and stuff like that, I guess. Courses taught in industrial engineering. I guess Miguel might be having difficulty unmuting himself.
The syllabus.
Yeah, syllabus. Yeah, I think that's what the main study plan is: syllabus, industrial syllabus, and main weaknesses.
Yeah, so I'm not actually too familiar with. So in the university that I graduated from, robotics is a different entity than industrial engineering. So I'm actually not too qualified. I didn't be interested to hear what you think about where you think the gaps are in industrial engineering as it applies to robotics and manufacturing.
Okay, that's a fair question. Fair comment. Okay. How the question? Oh, absolutely. Come in, James. Yeah.
Yeah. So recently, I had to undertake an accreditation exercise on an industrial engineering program at a Southeast Asian university, which was a fascinating exercise. It was actually very challenging because over the years that and I look, I understand that this has happened in many other places, but it may not be typical of every industrial engineering program. But what had happened was that the faculty had very little real experience of real industrial engineering, number one. Most of them were mathematicians. Secondly, the graduates of those programs predominantly were going into the IT industry, and they were building software systems which would, at some level, have to integrate with hardware. In other words, mechatronic systems. So, for example, automated warehouses, cargo handling systems, ports, and so on and so forth, where these systems were actually interfacing with real physical objects, and particularly concerned with freight and logistics. So that was an area in which they could apply their expertise. Now, the really interesting thing was that the faculty had become so divorced from, or so many of the faculty had become divorced both from industrial practice and also engineering as a discipline, that it was really remarkable that the graduates could actually make that jump and reach to some extent satisfying occupations. And as I understand it, this has become a problem in many other universities. So I hope that helps to answer Miguel's problem, or Miguel's question. But definitely, it's perhaps more so than in other engineering disciplines. Industrial engineering has become predominantly a discipline involving mathematics, and therefore the people who do research in the discipline tend to have a mathematics background, and they have very little contact with the real industrial world, less so than in other engineering disciplines.
Thank you.
Yeah.
But the students seem to rise to that challenge.
Okay.
So yeah,
One of
the things that I talked about in the presentation is there's not a clear free flow of information between industry and academia. And that's one of the things we're interested in trying to remedy.
Okay. Question, comment, another chat from the audience about the digital twin. A lot of talk about the digital twin. How can what is the role of the digital twin in the robotics field?
Yeah, so digital twins are a super hot topic right now. So for those of you who are not familiar with digital twins, they are the ability to have a simulation of the actual process that runs alongside the actual process. So you can use it for what we call virtual commissioning. So you can make changes to your manufacturing environment and then see what those changes will be like. You can also use digital twins for evaluating and monitoring the process you have running, along with many different things. There's one-way and two-way communication where there are parts of the digital twin that drive the actual process and vice versa. But it's an area, a really hot area. NVIDIA is pushing their digital twin software very hard right now. But it goes alongside industrial robotics and manufacturing. So how are robots going to behave in this environment when they're deployed in the real world, and then using these digital twins, which are essentially simulations, to monitor what's happening in real time?
Okay. Quick question on the, you had suggested there's a capstone project that the collaboration can happen between people from different countries, colleagues of different countries. So can you add a little bit to that you just meant?
Yeah. Right now, we have 4 different schools that are part of this pilot program, but we would like to add many more different schools. So the idea right now is each school is in charge of one part of the robotic system, and they have to work together in order to create a full robotic system. And the idea behind the capstone project is that this is run way more realistically and a lot closer to being a multinational company, where you have to source materials in different places, because one of the stipulations is that the robotic system needs to be built in all countries at all different institutions. So students will have to figure out what materials are available. They'll have to create drawings. They'll have to do documentation. They'll have to interact in a way that's not typically a part of the average manufacturing or robotics or mechanical engineering department. And they have to figure out how to get around cultural issues, how to figure out how to deal with language barriers and things like that. So this is something we would love to have more people from a very diverse set of backgrounds all over the planet if possible.
Okay, great. I don't see any other significant questions here. Any last minute comments, questions, please jump in. Otherwise, we'll hand this over to Hans Hoyer for his closing comments.
So I saw a question about humans and what happens to humans when the jobs. So that's a common question that we always have to address. So it actually turns out if you look at the data, those companies who are able to automate their processes are actually able to grow their workforce. And if you look historically at the application of technology, it is only the utilization, is that a word? It's only our ability to use new technologies that allows us to create new jobs, right? You can imagine that if we had the same jobs we had 1,000 years ago and would have never innovated. There's only but so many farmers and soldiers we can have, right? Technology helps us create these new jobs, and what the data shows us is that when manufacturers move forward with automation, that it actually helps employ more people in the long term.
Great, thanks for those comments. Last chance, any other comments? Otherwise, over to you, Hans. Are you there, Hans? Come on in.
1 second here, I'm having difficulty. Okay, I'm here.
Yeah, okay, go ahead.
Thank you very much, Krishna. James, it's a pleasure to meet you. I will be going soon to Sydney. I'm working closely with colleagues in Sydney to have our global conference in early December. Perhaps we could follow up separately. And again, I don't know where in Australia you are, if I understood it correctly, per se, but I appreciate it. I just want to let you know that, per se. Before I mention a couple of our global IFEES GEDC activities, just to keep some of you up to date with whom I'm working closely. William, one of the things I'd like to ask you, besides this presentation, which Krishna and his team is recording here, and the current 4 schools that you've mentioned, including Montenegro Tech, where we were just there at our global conference here last October, per se. I'd like to share, because I'm in touch continually with deans in all 6 continents and also organizations, and give it some thought, and perhaps we can follow up by a conversation of what I could share with a particular dean, for example, or organizational institution, for example, a member of the IFEES community. And I just want to plant that seed. I'm very happy to brainstorm. And of course, Krishna and I are also in touch, and we talk a lot about intercollaboration, particularly between Indian universities and US North American universities. So I just want to put that seed here in the conversation. Basically, just to do for 1 minute, just to give you an update, we'll be meeting the IFEES GEDC community now, meeting in Portland, Oregon during the ASCE conference, and there are a lot of things that we are planning per se. I just want to put this on your radar screen. I'm in close discussion, and we'll be traveling there very soon. 2 colleagues in Montenegro, Serbia, bringing together leaders, deans, industry people from that part of Europe, Serbia, and related 5, 6, 7 other countries. And we will have a conference there. And that's a whole new network, per se, that I've been developing and working with some very close colleagues and friends here. Just want to put this on your radar screen. Besides obviously the Sydney conference, we just made the decision also, and looking at the global connection, we will have our global conference next year in 25 in South Korea, without going to details on that. So that just reinforces also your interest, I know, William, in terms of the global connections. A couple of final things. I'm very happy, and some of you are deeply aware of that. We are about to complete our 5th volume of volume written by women engineering leaders throughout the world, and the volume now focusing on the Arab world and Southeast Asia is coming together beautifully without going to without further details. I'm very, very pleased about that. So James, I want to thank you for a very thoughtful presentation here and the wonderful attendance today, and Krishna, peace be with all of you. Stay healthy in these difficult times. All the best to all of you.
Thank you, William, and thank you everybody for joining us. And peace to everybody. Take care. Good morning, good night, good evening, good night. James, you've been up pretty late. We have time for bed.
Yes, thank you. 15-hour difference for me.
Okay. Good night, good morning, good day. Bye-bye.